Hello and welcome to Digital Wood Carver. My name is Laney Shaughnessy, and in this video, I'm going to talk to you about limit switches on your Digital Wood Carver 2440. We're also going to talk a little bit about the mini carver as well. However, I don't have a mini carver here in the shop to discuss how you would connect or possible options for connecting proximity switches or limit switches to your machine. So we're going to kind of focus on the 2440, but we will break away and talk about the mini carver also. Now, our commercial units, our DWC 4848 and our DWC 5100, they have limit switches built into the systems. Our mid-size unit, our DWC 2440, and our hobby unit, our DWC 1824, do not. And so there is an option of, adding them on yourself, kind of DIYing it. Now, I am no expert on limit switches, so this video should serve more as a guide to point you in the right direction and not an albeit this is exactly how you do it. Now, let me say this and really stress this point to you guys and girls that are watching. When it comes to altering or modifying your CNC machine, do your research and do your homework and everything, because this particular topic isn't necessarily sanctioned by Digital Wood Carver. Burl Tishner, the owner, did not reach out to me and say, "Hey, Laney, I want you to do a video on how to add limit switches to the unit." Right? I had a customer reach out to me and say, "I'd like to be able to add limit switches and set a fixed home position. How would I go about doing that?" And that's what spurned or spawned this video. And so with that, I did my work because I'm not an expert on limit switches, and I researched the best limit switches to use, and I found what I think are the better option of all of them, and I'll share where I got those from and all that information. From there, I reached out to Planet-CNC because we use the Planet-CNC controller board inside of our control boxes. And I talked with Andre over there about how to connect limit switches to the Planet-CNC controller board. He gave me the insights and he gave me some information, and I've got some web pages for you to look at here in just a moment, talking about capacitors that would be required, or possibly optocouplers that would be required, and different hardware and stuff to connect it properly. And it was getting a bit involved for me, and so I reached out to Burl, and I had a brief discussion with him as to, I'd like to do a video on limit switches, but Planet-CNC requires all of this. What are your thoughts? And we had a brief discussion, and we come to talk about, yeah, we'll go ahead and add the capacitors, but we won't add the octocouplers, and it should be just fine. Should be just fine, right? And so far, everything has been great, right? But you watching this video and thinking about adding limit switches to your machine, you have to take it a step further and do some homework. Take this as a guide, as a stepping stone towards the end goal, and you have to make that internal decision for yourself of, yes, this is something I want to do to my machine, or no, it's not necessary. Now, we do not add limit switches and proximity switches to our mid-size carvers because they're not really necessary for the purpose of the machines and things. They are there to help limit movement. They're there to help with initial setups with a fixed home position on the table. What your current setup is what's called a variable home position, meaning that you can clamp your material anywhere on your table, and you set your home position, your X, Y, and Z 0, right at the beginning of the job for every job you do. With proximity switches and setting a fixed home position, that means that the machine will do a homing procedure, and at the end of that procedure, it is homed the machine position. And then, of course, from there, you have your work position where your material is actually clamped on the table from that machine's home position. And that changes how you do your designing, offsets and things like that. Your home position is here, your material's clamped over here, you're working off the bottom corner of your material. What is that distance from your home position where that board's clamped on the table, that offset distance? And you've got to know those things, and you've got to incorporate them into your designing when you're working with that type of setup. Now, I have within the software, I'm going to show you how to set up a home position. I'm going to show you everything that I did to the 2440, my 2440 here, for the 3 proximity sensors. Some people add 1 on each end, the x-axis travel, 1 on each end of the y-axis travel, 1 on the z travel. I've only got 3 proximity sensors on here, 1 going in the x positive direction, y negative, and x negative to set my home position. From there, I've done what's called setting soft limits for my extended travel, my 24 or my 40-inch travel area, so the machine kind of stops without a sensor being down there. I'm going to show you all of that set up in the software and talk you through it. Now, again, you have to make that internal decision whether you want to do something like this. If you do decide that you're going to go down this rabbit hole or down this road, you need to, how you connect your sensors and everything, you need to be absolutely careful in how you proceed. I'm going to show you the things that I've done, but you have got to base your ability to install these on your skill level and things, and think about alternatives. I've experimented with, I saw a video where someone hot glued their sensor to the different places of the machines, their sensors, and they use hot glue to kind of affix them in place. I did not like that approach, or I didn't think that was a very good approach. I wanted them permanently fixed if I was going to. So that required me to drill and tap the different areas where the proximities were going. And when it comes to the Z, as you'll see when we move into the software and all, I'm actually drilled and tapped into the side of one of the guide bearings. And if you're going to do something like that, you need to know exactly where you're drilling, exactly where you're tapping, and that you're not going to damage your bearing or your machine in any way. That this is, if you're going to put these on, it's meant to be, I guess, if you will, an enhancement for you, or a nice little setup for you to home your machine out accurately and repeatably. But at the same time, with installing it, we don't want to do anything to damage it. We don't want to, wire it incorrectly and possibly, damage our control board or something because we didn't wire it properly. These things get expensive and they're not covered under warranty or anything like that. So you have to make the educated adult decision that, okay, I'm going to do this and you're taking on the responsibility. Okay, so I've got to get that disclaimer out there, and I've just got to let you know. And I'm not saying that to scare you away from doing it and stuff. I just need you to use your common sense, your own gut feeling, and your expertise as far as your mechanical ability to do it properly and not damage anything that's going to affect the operation of your machine or cost you more money than it was worth, kind of thing, right? Okay. All right. That being said, let's go ahead and let's get into it, and let's talk about the first thing. What kind of sensors did we go with? So if we switch over to our screen here, the proximity sensors that I purchased came in a 3-pack, which was perfect because that's all I was putting on my machine. And these are the CommiMark 3-piece. They are the TLW5MC1 5mm 3-wire inductive proximity sensor detection switches. They are NPN, normally closed, and they are the DC 6 to 36 volts. Now these have a limit of a range of sensing range of about 4mm. Depending on the type of material that you're going to use. I purchased these off of Amazon. As you can see, for the 3-pack, they're around 11 bucks. These are the ones that I purchased. So I wanted to bring them up on the screen so you could see where what they were. Okay, so these are the ones I worked with. I've not worked with other limit switches. I did my homework, and these were the ones that I found to be the best option for me and the digital Wood Carver 2440 in my shop. Okay, from there, one of the other things that I had to purchase was a 100 NF capacitor. The 100 NF capacitors, 50 volt low voltage ceramic capacitor. And I went to a local electronics store. You can buy them online, but I have a local electronics store here in town that sells computer components and things like that. I purchased a 5-pack, and it cost me 50 cents. Of those, that little 5-pack, I'm using one of them. Now, Planet-CNC recommends one ceramic capacitor per sensor when you are wiring through what's called an optocoupler. And we'll talk about that a little bit more here in just a moment. Now, I didn't wire mine that way. I didn't wire through an optocoupler. I wired direct to the board. So all of my voltage wires are tied together as one. And so I have one of the 100 NF's capacitors on that connection and everything. So that is one of the things that I did add that would be needed. Now, if we come back to talk about the sensor, this little chart right here, this sensor is the TLW5. It could be the MC1 or some other letters. In my case, I have the MC1. And this talks about the different sensing ranges based on the material that it's sensing. And you'll notice that copper is low, about 1 millimeter, followed by aluminum and brass, stainless steel, and iron. Now, for me, I went to Lowe's, and I purchased a 3-foot stick of zinc-plated steel. In the description of this steel, when you go to Lowe's, it's described as a 3/4 inch wide by 7/64 inch thick zinc-plated steel. It's about $5 or $6. But it actually measures 1 inch wide. So I'm not sure why the description is wrong on that, but it is 1 inch wide. It comes in a 3-foot length, and this is all I have left. And what this is I use this steel rod. I cut off pieces. I bent them into 90-degree angles, and I mounted them to different locations on my machine, which you'll see in a second, to be the device that the sensor senses. The part that the sensor senses to stop that movement and everything. And so if we look at the chart here, I'm with that zinc plated steel, I'm probably right in the 4 millimeter range between iron and stainless steel. So I'm probably right about 4 millimeters on the sensing range, meaning that proximity sensor, that part needs to be within 4 millimeters to sense and activate and everything. Now, if I scroll down this data sheet on these sensors, if I scroll down to the part that I need, and let me minimize this out a little bit and we'll zoom back in, but let me find my right section here, which is this section right here. Let's go and zoom back into that and move over here to the wiring diagram, what we see here is we have coming out of each of the sensors, we have 3 wires. We have a brown, a black, and a blue. Your brown wire is your voltage wire. Your black is your signal or your load wire. And then your blue is your ground. And on that voltage wire here, prior to going to the power supply, is where that 100 NF capacitor is located and everything. So brown is your voltage, black is your load or your limit wire, and blue is your ground when it comes to that wiring. Now, if we go over and to Planet-CNC and we look at what an optocoupler is, a optocoupler is basically, it's a photo sensing cell. It's kind of a break in the signal. It's a photo sensor, and Planet-CNC recommends that each limit switch be connected to an optocoupler, and they sell optocoupler devices at their website and things. And Andre recommended that each sensor be connected to that, and I didn't want to go that route because I wanted to try to get through this video and just give a little bit of a guideline, but I also wanted to provide all the information that I could to you. Now, these optocouplers can be connected via a 12-volt power supply or a 24-volt power supply. And on here it shows the different connections, how you would wire those up and to the controller board. But what I want to transfer over to is the connection of the proximity switches, and we're working with an NPN connection here. And so on the proximity switch, our ground wire would go to ground. The voltage, the brown wire, the volt wire, would run through a 1K capacity if I was working with a 12-volt power supply, or a 2K2 resistor. I said capacitor, I meant resistor, sorry. If I was working with a 24-volt power supply, they would connect into that optocoupler, and then from that optocoupler, we would have our limit pin and our ground pin going to the controller board, and so that would be the wiring. Now, I, again, did not follow this procedure because I did not add an optocoupler. I wired direct to the controller board, which you're going to see. And again, you're going to take this as a guide, but you may want to do your research. Planet-CNC, they highly recommend going through an optocoupler, but an optocoupler is another switch, so there's a bit of a delay in that as well. So the one thing that I had a concern about, which of course it's an unwarranted concern or an uneducated concern, because I don't know enough about the circuitry and stuff. But the concern I had was that that delay in that switch, that optocoupler, activating and deactivating versus a direct connection, would that delay affect my my operation in any way? Would it cause any kind of interruption? But that I didn't want. But at the same time, in Andre's words, proximity sensors are a prime source of interference, electrical interference. And having the capacitor and having an optocoupler helps break up that signal to remove or reduce that interference, so it doesn't affect any other part of the operation of your CNC machine. And I have not seen where any interference is affecting the operation of my machine, but at the same time, it could present itself down the road because I did not wire it, according to these diagrams or recommendations. I wired it direct. Wiring it direct works for me. It works exactly as I want it to and hoped it would. And I have not experienced any interference. However, it could be something that could present itself, right? Could possibly present itself in things. And we have to take those things into account. Again, I'm just trying to provide the information or the insight as to my approach and what I've done as a guide. And then from there, you take it to the level that you want to take it for your machine, because that is your machine and your responsibility on how you do that. Okay. I'm just kind of giving you a little bit of a stepping stone, if you will. So with that, now that we know, where I got the proximity sensors, and I got them from Amazon, and what kind they were, the steel. Now my screws and my tap and everything, I'm using a number 4 screw that I believe is 3/4 inches in length, machine screw, and they're small little suckers. And I bought a tap and die set that had that particular tap in there because I wanted to drill and tap. And so I got the little drill bit and the tap with that so I could do my work. The one thing that, the one obstacle that really challenged me was positioning, where to position these, especially down on the x-axis and everything, where to position these, that not only could I drill, but also use my tap. My tap had that T handle and everything. I ended up having to cut the T handle off the tap and shorten it up so that I could turn it to tap in there without hitting the bars. When I was tapping the screws, that long T handle wouldn't let me turn, so it wasn't very productive. So I ended up having to cut it down. I used a hacksaw to cut that little T handle down. Had to alter the tap it, so I could get things tapped in there. So my biggest obstacle was, bending the steel, right? Getting it a nice bend in it, and a 90-degree, and then cutting it off wasn't a problem. But bending the steel and getting the parts to size. But the taps, where I can drill, get a drill in there to drill, because I'm drilling in aluminum and things, especially down on the x-axis and everything, where I could drill and place that, and then also to be able to tap the hole, right? So I had to be able to tap it. So that was my obstacle. That was the biggest challenge, and I took it one sensor at a time, and I took my time. Because this was going to be permanent, right? So once I drilled and tapped, those holes are there forever, right? So let's look at the different sensors one by one and talk about them individually as far as the placement of them, and then we'll look at the wiring, how I've got everything wired. We'll take a look at an MK3 controller board and the wiring I did to show you how I routed the wiring. And then we'll jump into the software and we'll set up the software for the homing position and set up our limit switches and our soft limits. And then we will move around and show you how I configured everything to, after that homing procedure and stuff. So let's start with the limit switches themselves and their locations, as well as where I put the material, where I put the object that was going to be sensed, where I located those and installed them, and we'll go from there. All right, so the first limit switch I'm going to talk about is my Y minus limit switch. So now everything is, so just so you know where the positions, the Y is on the Y minus side, X is on the X minus side, and Z is on the Z positive. Okay, those are the 3 locations that I set up. Now, on the gantry arm of the 2440, just above the belt, there is a kind of a pre-drilled hole there. And it comes from the factory that way. I'm not sure exactly, that hole is for something. I'm not sure exactly what it's for, but I used that for the place to route my wires so it could tie into my other wires down to the control box. So I ran the wire through the hole, to the sensor. And so I placed the sensor based on where my object was that was going to come in. I'm just right below that top bar. And if we look at the object here, let's get up here. My 90-degree object is this piece of steel right here that I bent 90 degrees, and that object is screwed to the upper Z-axis bearing. The lower bolt of that bearing, just that single bolt, that is where I drilled it so I could take that bolt out and then put it back in with this in place. I do have clearance below my rod so it can move freely without rubbing up against my rod or anything. It looks like it's right up on it, but there actually is a gap. Let's see if we can see that gap. There actually is a gap there and everything, but this is the sensor, the object being sensed and everything. And I had to take an account that, okay, how tight I could bend that 90 degrees. So how tight I could bend this 90 degrees, that has it stick out from the back plate, a pretty decent amount. And so with my sensor, when that comes in to my sensor here and everything within that, 4 millimeters away, that's going to be my maximum travel, right? In that Y minus direction, which is great. It worked out just fine. It's traveled exactly to where where I don't carve on my machine anyway, and it's not taking away anything from my full capacity. I'm essentially in a safe zone that I'm not going to hit my limit anyway. Like if I didn't have this sensor here, I could ram into this if I go too far in Y minus. But now I've got the thickness of the sensor here away, and then of course that bend, right? I bent these with clamping it down and bending the steel and getting it into that 9-degree shape, cutting it off to the size that I wanted, and then drilled and removed that lower bolt of that bearing and put it in there and all. And so these things take into effect. And so if we focus on one sensor at a time, and I come over here to the, let's see if we can get that pointing up a little bit. If I move my Y-axis over, okay, so if we look here, you can see that sensing range, basically the gap between that sensor and the material, that's where it is stopped. If I move away from that location and move back, that's where my sensor stops. And there is a little LED red indicator showing that it's on. So now, stepping back and looking at the machine, this is my maximum travel distance on my Y-axis, which I could only go a little bit further anyway before I hit my limit anyway. So I probably maybe lost about an inch or an inch and a half of Y minus. But my fences and everything are way over here, so where I clamp my boards, so that's fine. It's within my area anyhow. So location, 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 just like real estate. Make sure that we're in that proper location. So I'm going to come over here, and I'm going to take my piece of steel rod here, and we should be able to see that red light that comes on right there when it senses, depending on its location. That's what activates and stops the movement. So whether I'm going relatively fast or slow when traveling, it's going to stop at that location, right? So that's what the limit switch does. Okay, so that is my Y limit switch location, and the little object, that's not little object, but the steel bar object, its location, I put it on that lower bolt of this upper bearing, and that's where it is located. I bent it the best I could to a 90-degree angle. I couldn't find nice sharp angle steel that was already bent into a nice bend. If you have a metal brake or something where you can get a tighter bend on that, that'd be cool. But mine is more of a radius bend. You can see that there and everything. And so I worked with what I had, and but I did want this zinc steel because it of all the materials I tested, it sensed the way that I wanted it to sense with that sensor. All right, now let's take a look at the Z-axis sensor, which we're already here. And my Z-axis sensor is located, and let's bring that Y over a little bit more. And let's bring down that Z some. Okay, so now this sensor, as you can see, and I'm going to actually freehand the camera again. This sensor is literally tapped and drilled into the side of that bearing housing. And there is, if we can look down in the sensor where the bearing is, there is a small amount of lip above that bearing inside. Let's see if I can, there's a small amount of lip in that bearing, and my screws go right through there. Now, the one thing that I had to be absolutely very careful of is when I was drilling the holes, that number one, that I'm not drilling into my bearing, right? Don't want to do that. And number two, when that drill came through, that I did not ram into and damage my rod, which if I dimple or damage my rod, that could affect or catch that dimple or damage of that rod. Instead of being nice and smooth, it could catch on those bearings when it's traveling up and down, and that could damage and affect my machine Z operation. So I am talking that I absolutely took my time when drilling this. I made sure that my drill was going to come into this open area up here inside that bearing, above the bearing and all, that my screws, when they go into here, they're only 3/4 inches in length, so they do not protrude into this rod area, this well area here. So they only go back, so far. So I used that number 4 3/4 inch screw and everything, and I tapped that. And when I was tapping, I needed to tap, enough to get that screw tightened down. So now this was the most difficult in a way for me, because I did not, any damage to this bearing or that rod is going to absolutely affect the movement. So, but this was the ideal location of every location. I looked everywhere. Where can I put this sensor? Where can I put this sensor? And this was the only location that I could find that was suitable. So, if you come up with something different or what have you, wonderful. Okay, but I need a fixed location that when my Z is traveling up and down, as you'll see here, when I travel the Z up, okay, when my rod senses, that red LED light kicks on. And the metal bar here, if we look closely, let's drop this down on the sensor. Let's look at the sensor closely. There's a bullseye right there. And I've got this rod cut off, because once it hits that center line on that bullseye, that's when the sensor senses it, when that material gets right up to that center line. So that's when that sensor senses. And if we look again, if we watch the travel up, you can see I'm right at that center line, right? And that's where my sensor is activated. So I've got that rod bent and everything there, and I got it cut off there so that I could get the maximum travel up. If we look at my absolute maximum travel, I am right at my limit. And what I did, how I determined, I couldn't go any higher anyway, possibly a small amount, right? But I'm right at my limit pretty much. But what I did is I raised my Z all the way up to its limit. And then I, from there, backed it off a small amount, a few thousandths of an inch. And I determined from where my sensor location is, where my rod needed to be cut off, my steel rod needed to be cut off, so that I get maximum Z travel on my Z up, Z positive, without hitting the limit, of course, you know, not the limit switch, but the limit, the machine, like go any further than it can. I wanted to get the maximum distance of travel up, but also where my sensor senses before I actually hit the limit, right, and mess up and lose my position and stuff. Now let's look at the actual part itself that gets sensed. Now this part, again, I took a piece of that steel bar, and this rod here, this Z rod, is attached to the top of this plate by this bolt here, and also there's one at the bottom there. It's a very short bolt, so don't use thick material, but what I did was I removed this lower bolt, and I took my time removing that. I did not want to damage the threads on this or anything like that. You know, I didn't want to strip it out with the Allen wrench and all. It is Loctited in there, so I took my time to break it loose, if you will, and then remove it. And then I had to bend my metal and, of course, you know, determine my length. And my metal was long to begin with. It ran long to begin with and all. I didn't cut it right to size to start off with. It ran long. And what I did was with the bolt out with my piece of metal, I held it up against this plate, and I looked at the distance between the plate and sensor, how far it needed to be away from the sensor to read it, and I determined where my hole on this part here, where my hole needed to be drilled, that when I screwed this thing in, that 90 degrees went exactly where it needed to go. Now, of course, this is metal. I can flex it, right? If I flex this, if I take and look at that sensor, that red light, if I flex this even ever so slightly, you see it's not sensing, right? And I am, you know, I need that that metal to be a certain distance away so that it senses. Okay, so hole placement where I drilled that hole so I could screw that bolt back up into that rod. And do not move your machine around when that bolt is out. I had it raised up, and my machine did not move up, down, around, or anything like that until that bolt was back in its place. You know, because I did not, again, want to damage anything with the rod and all. So I found my location, I drilled my hole, screwed everything back together. I've got that part going up, and it's just the correct distance away from the sensor and all, and that is my part, right? And I can get full Z travel down. You know, I can go all the way down to my wasteboard and everything, and then, of course, when I come up to my sensor, it's going to sense and stop, and I'm not hitting my limit, so I'm not losing that position. Also, that's one cool thing. I'm not hearing that that noise when you go up too high on your Z, right? So that is my Z sensor and its location, and how I attached the sensor and the steel bar that got bent and placed into position. And placement is everything on that sensor, right? All right. So now that takes me to the X-axis. Okay. So we're going to take a look at the X-axis now. So we're going to travel down here into Darkland. Now, on my disclaimer here, I have the joint making jig for my digital Wood Carver 2440. So therefore, I have my 1-inch riser blocks, extension blocks that extend my gantry so it can carve past the front of the table. And it's not just the gantry arm coming up. If it was just the gantry arm coming up and I didn't have this extension bar, figuring out where to mount this would have been, the sensor would have been tricky. I would have had to, if it was just my gantry arm, that would have brought my gantry back to here, of course, where these two bolts are, would have brought that gantry arm back to that location. for where the sensor needed to be, it would have to be on the inside face of the gantry arm here. So in order to, if I would, to position it, I would have had to drill and tap on the inside of this face, meaning I would have had to remove the gantry and drill and tap the inside of the face where I could mount that sensor on the inside of that face, right? But I happen to have the extension bar, the 1-inch riser block and extension bar, so that allowed me to take a piece of aluminum angle iron, and my sensor is screwed to that, so you can see how it's offset because of that aluminum angle iron. But I down on the face of this extension block, making sure you see where the location of that bracket is, and you look down here at the location of those 2 bolts, making sure that when I was drilling and tapping that I was not running into this bolt or this bolt hole or anything like that, right? So my location here, number 1, I was able to drill and tap that angle bracket, have the proximity sensor mounted to it, and then of course I could run my wire into the other wires, right, going to the control box. Now comes where I placed the sensor as far as it could go, and then I backed it off ever so much. And so if I move right now, if I move the X to its limit, notice how it stops there. If I move the X all the way to its limit and I come down here under the machine, you can see how close I am before I would have hit the end of my table, right? So, and the lighting's not the greatest and everything, or the positioning is not the greatest. Let's see if we can get in here. But you can see that distance, right? I am at my extreme limit almost, but I ran it all the way slowly into here as far as it'll go, and then I backed it off a bit, and that was my location where I wanted my machine to stop for the limit switch. And so the up here, my router has to be able to hang off for my joint making jig, so that I can mill my dovetails and finger joints and all that on the jig that mounts on the front of the table. And that is the maximum travel of distance that I can go here with my router bit, the center of my bit, which will allow me to carve, up to, I think, 1 inch thick material, 1 1/4, something like that. But so all of these things get affected. Now, if we go back and look at the limit switch, remember I said about the bullseye on that limit switch, that halfway line. Well, if we look at where the steel rod is located, and you can see in the black reflection here, it's a little dusty, but you can see that little red LED light reflecting off of that. But look at where the location is of my steel rod. It's not covering the full sensor. It's only half of it, because once it gets to that bullseye line, that's when it starts sensing. So if I, were to move away here, when it is traveling to that, it's stopping there at that half line of that bullseye. So I had to move my machine all the way to its extreme end and back it up. Then I had to look at where my sensor was located and kind of indicate where that halfway mark is. And that's where the edge of my 90-degree steel rod was going to be located. And then I had my 90-degree piece of steel rod. It's right underneath the table. You can see where it's located at. It had to it's mounted to this steel square tubing here. But it had to, that 90-degree bend. Remember, like I said, I didn't get a tight bend and all, but it was, enough. So I made it a little extra long so I could, figure out where the position was. And where it mounted was the right edge of this thing, the center basically, needed to be mounted on the frame in a place where the right edge of this allows that sensor to sense, when it stops, it's going to sense, and then, and not hit my limit. Let me fix my ground here while I'm down here. Put that down there. And everything. Now on this one, not the best slot in the world, so ignore my drilling work and all, but this hole that I drilled was in the center of this tube, but on my steel rod here, I made it a long slot. I drilled a couple of holes and I filed them and everything so that I could loosen this up and slide this in and out until it was in the position where it was far enough away from my sensor that's in there, you can see down there, so that, and if we move back to the location here, you'll see the sensing distance. Okay, and now this 90-degree bend, this 90-degree bend right here, you can see I'm at the top of my sensor. That metal is, how close it is, but you see at the bottom of the 90-degree, there's a gap there. Well, it's actually reading up here, this lower level and everything. So that 90-degree bend was important, but I was able to slip my metal stock in and out till I got it to sense, and then of course tighten down the bolt for its permanent position. I was able to get that located and then tighten down that screw. And it's, again, all of these are the screws are number 4 3/4 inch. And this one, actually, I put a nut on the screw head to act like a washer, so when I tightened it down, it locked it down. And that is being, in the bottom of the square tubing and everything. So that is the location and the setup of all 3 of my sensors, X, Y, and Z. And now let's talk about the wiring and how this was wired up. Now, number 1, my Z sensor, the wires from the sensor are only so long. X and Y, my Y location, my X location, great. Nothing wrong with the length of them. I was able to route them with the rest of my cables and into my little connection bar, which you'll see in a moment. But my Z had to travel through the cat track and follow the other cables. It had to come around my Z sensor. I came up and zip tied to my router cable and everything, and it had to travel into the cat track, around, and out with the other cables. So that required me to splice, solder and splice a cable in there. And this cable, this 4-conductor motor axis cable, you can purchase from us, Digital Wood Carver, by the foot. You can purchase that from us. It's a phone in order, so you can call us if you need a length of it or so. And so my sensor cable stops right about here. And from there, it's the gray cable that it's soldered to going down to my connection. Now let's take a look at the connections and where they're all running into. All right, so I have this hobby box that I ended up purchasing, this metal hobby box that I ended up purchasing, and it's I use Velcro, and it's Velcro to the top of my control box. We're looking down onto things now, and if you open up the lid, you will see that I have this connection bar in here. And let's get into a position where you can see all that clearly. And on this connection bar, all of my proximity sensor cables come in, and then I have one cable that comes out and to the controller board. So let's look at this real quick and understand what we've got here. This terminal bar is, I purchased it from Lowe's. It's just a terminal bar that has 1, 2, 3, 4, 5, 6, 7, 8 terminals on there. And I forget, it was just a couple of bucks, but I bought that. And not only do I have my proximity sensors coming into it, but I also have my touch plate, my touch block, my DWC quickset block, and my 4th axis touch off sensor wires coming into this as well. And so let's see if I can walk you through this to let's see if I can get the focus to focus in here, and let's see if I can walk you in this without it being so blurry. No, looks like a nest of wires in here, but on my hobby box, I drilled holes for my axis cables to come in, and then I have one wire coming out that goes into the control box to the Planet-CNC controller board. We'll talk about that in a minute. But I am using the 5 screws here for my sensors. 3 of them starting back here. We have on my sensors, we have the x-axis, y-axis, z-axis, and then I have my ground and then my power. So 5 wires. Now this gray wire here, this gray wire is 4 conductors, red, white, black, and green, but there's also a bare ground. Now I took some shrink wrap and I shrunk wrap some bare ground wire. My bare ground wire, I took some shrink wrap, and in my shrink wrap, I got a little tube shrink wrap that was about the same size as the wire, and I coated or covered my bare ground wire so that it wasn't bare all the way through. So I've got for all 3 of my limit switches, all of the brown wires are connected together on one terminal here. And also a red wire, because the red wire, remember, I had to splice one of my gray wires for the Z-axis cable, so it's red, and so that's under that terminal screw there. And then if we look here between the 2 terminal screws, I have that ceramic 100 NF sensor right there that's screwed between those sensors. And then my red wire comes out and back into the control box. So red is my voltage going into my controller board. Then I had all of my blue wires and the green wire from the gray wire. But my blues, those are ground. And I connected that to the black wire going out to the control box. My black wires, which is the load, each of them are on, each of them are on their own screw, Z, Y, and X. Each of those are separate. I do not want to tie those together. Ground and power I can tie together, but X, Y, and Z need to be separate. So they're on their own terminal. And then I have my black, white, and I'm using green here going into my control board. Now, on the other side, just so you know what this is, on the other side of this, I have my touch plate sensors coming out. So from my control box, I have one wire that goes out to my touch plate sensor, or to my control board. And from there, I have daisy looped these to activating all 3 of these. So all 3 of these screws are sensors. And from there, I have a wire going out to my DWC quickset block. I have a wire going out to my touch plate, and I have a wire going over to my 4th axis touch butt and everything. So all of these are my 0 sensors there. And so I have that one wire going out into the input number 2 on my control board, which we'll talk about here in a second. And then, of course, my ground, as you saw earlier when we were looking at the X-axis limit switch, my ground is gator clipped to the leg of the table. The ground does not come out of this terminal bar. It comes straight from the control box. So this little terminal bar and this little hobby box is what I put together. And of course, when everything is together, it's got its lid. I got some Velcro on the bottom here, and it Velcros right to the top of my box. So it's facing all the other wires that are going into the control box, this nest of wires that I have got to clean up down here and stuff. And so as we come down now in front of the control box, and we'll back up here and get in front of the control box here. I have to drill an extra hole in the front of the control box for my limit switch wire to go into. I have a hole here that my ground and my sensor wires go into. I have a hole here for my, oops, sorry. I have a hole here for my probe wire. And then I have a hole here for my laser. You guys, I did a laser video on installing the laser, so there's a hole there. So these are all, they're all right directly underneath the A port or your X, Y, and Z ports. Made sure that when I was drilling those holes that I was not drilling into anything inside, and those wires are running into the control box. In the front of the control box. And then of course I have my X, Y, and Z, and I've got my A unplugged right now so we could see these wires and stuff, but then they are all zip tied running up to the different sensor locations, and then into my cat track to my different motors and everything. So that's my trail. Now I would like to, if you look at this here, these wires and stuff, and when I put my hobby box back on and all, I would like to do something with this cable management. This is not ideal for me as far as looks and appearance and stuff. It's fine if it was just the XYZ axis cable, but I have all of these cables here, and then eventually I'm about to here this week I'm going to be adding a water cooled spindle, so I'm going to have more wires coming in. So I've got to do a little bit of cable management and figure that out. If I come up with a solution or something that's presentable, then I'll make a video on that and talk about that some and stuff, which again, that would be involved as well. So the wires are coming from the proximity sensors. They're coming down the cable track, and they're zip tied with my X, Y, and Z axis cables and things. And then the sensor wires go into that little junction box there, hobby box, whatever you want to call it. I purchased it off of Amazon, and I bought that terminal bar. 8 little terminal bar from Lowe's. I believe it was like $5 or $6. I'm not sure exactly how much it was. And I have all of my browns, my voltage wires, they're all tied together onto one screw terminal. And then I have a volt wire coming out of the other side of that terminal block going to my control board, to my 5 volts on my control board. I've got all of my load wires, basically each one of those sensors. They're all independent, X, Y, and Z. They're on their own screw terminals. And I've got 3 wires coming out to the control board to limit 1, 2, and 3, which you'll see in a moment. My grounds are all tied together. And then they go into one of the screw terminal blocks. And on the other side, that comes out to the ground on my control board. On the voltage, the brown wires and everything, where I have them in and then going out to the control box, I have that 100 NF sensor or capacitor connected there as well and everything. And again, it's not according to the recommendations, but it is, as far as if I was direct wiring to the board, exactly how it would be wired. But if you want to go through optocouplers and things like that, and you would put 100 NF capacitor per limit switch, you can go through your octocouplers and you get yourself a little hobby box, and you can put those octocouplers in there and then come into that and then come out to your control board. Right? You may be able to find room inside of your control box. However, I wouldn't really put it inside the control box, because if you don't have a laser and you wanted to have a laser, you got to have room in that control box for a power supply that's going to go in. If you're going to add a water cooled spindle, there's another main relay that gets put in there. So that real estate inside the control box is precious to me because of all the actual components that come from Digital Wood Carver, like the digital laser, the water cooled spindle, and things like that. I need that real estate in that control box for those items. Now, Planet-CNC recommends, if we're going to hook up octocouplers and stuff, that we would connect them with an independent power supply, 12 volt or 24 volt. And in those sheets that I showed you earlier, those web pages that blog on Planet-CNC, it shows about connecting a power supply to the Optocoupler and then, you know, to the limit switches and stuff. I did get a little 12-volt power supply, but I ended up not using it. I'm just going straight to the control board and all. So down the road, I'll talk about videos about adding a 12-volt power supply to your actual control board, so it's kind of powered by that instead of the USB cable on your computer. Things like that we'll talk down the road. These are all modifications that could be done, upgrades, not upgrades. That's a bad word. It's not really an upgrade. It's just an option, alternative way of connecting things. We'll get into that. And again, these are not sanctioned videos by Digital Wood Carver. These are just things that might be, you know, FYI. And if anybody is going to talk to you or kind of guide you in the right direction on where to start on the things that you might alter on your machine, I'd rather it come from me than somebody that doesn't know the Digital Wood Carver at all. Okay, so let's take a look at a control board, and let's talk about our 5 wires that are coming in from that little hobby box into our control board. Okay, so here is an MK34 control board, CNC USB MK34 control board. On the front here, we have the USB where you guys and girls plug in your USB cables. On the side here, we have our different inputs, outputs, and limits. So if we were to look at this, let's turn this to the side so you guys and girls can read it. We have our control, input, limit, and output. Output is where our router and vacuum are, our water-cooled spindle if we have it, our laser. That's our outputs. The inputs, that's your tool sensors, your touch plate, input number 2, and everything. And limit here, that's our limit switches. So we have a ground, limit 1, 2, 3, and 4. Now, if you decided that you wanted to put 2 limit switches per axis, X, Y, and Z, actually both of them, your X minus and your X positive, your Y minus, your Y positive, your Z minus, your Z positive, they would be wired into the same terminal, up to 4 axes. Depending on the direction you're moving, determines which limit switch gets activated and things and all. So, but for me, I have 1 wire coming into ground. I have 1 wire coming into limit 1, which is the X-axis. Limit 2 is the Y-axis. Limit 3 is the Z-axis. And I do not have anything on limit 4. So those are where my axes come in. So on my limits, I have my limit 1, 2, and 3 for my 3 limit switches, X, Y, Z. And then I have my ground going into that terminal block. So out of that panel box, I have a 4 conductor wire with the bare ground. Again, I covered the bare ground with shrink wrap or shrink tube and heat shrink, if you want to call it that. So it wasn't bare, you know, in there in the box or anything, and it went to ground. And then I came around the corner to the 5-volt here on axis number 1 and connected to that, and that's how I connected my limit switches. Okay, so this is your MK34 controller board. Now, I said we were going to talk about the mini carver and all. I have decided that we're going to do a separate video on that, and I'll discuss the connections and everything would be the same. You'd find the location where you're going to mount the limit switches. You're going to find the location of how you would connect the little material, your steel raw bar or whatever that's going to be sensed. And then you would wire into the control board for the mini carver. But create a separate video just for the mini carver on that connection, because this one's running into some serious overtime here. Again, we just got 5 wires coming in, ground, limit 1, 2, and 3 for our limit switches, and then a 5-volt coming back here and connecting to the 5-volt. Anywhere there's a 5V if it's open, but output's already used on y'all's boards. Output the 5-volt, so I just came around and used the 5-volt over here because they're all tied together. Okay, so that is the connection on the control board. And Now let's talk about the software. All right, so that is a basic rundown on how I attach the proximity sensors for the limit switches to my digital Wood Carver 2440, as well as how I wired them. What I will try to do is provide in the link, a link in this description of this video. I'll try to put together a PDF of the wiring configuration of how I wired it, as well as how it would be wired through octocouplers and everything and all. So I'll do my best to put those schematics together and create a PDF document for a download for any of you thinking of doing this. And again, like I said, in a separate video, I'll talk about the mini carver because we're running into a little bit of overtime here talking about 2440 because it is pretty involved and we haven't jumped into the software yet, which we're doing right now. So let's go and look how we would set up our limits and our limit switches in the Planet-CNC TNG motion controller software. All right, so the first thing that we're going to go to do is we need to go into the file menu and into the settings of the software. All right, in the settings, there are 3 different places that we need to go. Limit switches, limits, and then scroll down and our home section. And I'm going to show you how to set up each of those sections. Let's first start with the limit switches themselves. And in here is where you will tell the software where the location of your limit switches are and what number they are. X-axis is limit number 1, and it's on the minus side of the machine. The y-axis is limit switch number 2, and it's also on the minus side of the machine. And the Z limit switch is number 3, and it is on the Z positive. So we've got those 1, 2, and 3. So that's our locations. Now we're going to jump down to the home position setup. And in the home position setup, we have our sensing speed. There's a high and a low. So when I do a homing procedure, my machine is running at 20 inches per minute, and it is doing its initial sense. Then it's going to back off, and at a slower speed, I've got it set to 5 inches per minute. It's going to come back and sense a second time to really get a good reading before it sets that parameter of 0. In the order that it runs, I have the Z sensor activate first. So the Z goes up, and it is first in line. So it does it sense first, followed by the Y. It comes over and senses the Y sensor, and then the X. It comes to the X minus position and senses that. So that's the order that the homing position runs in. Now, the direction of travel for the sensors, again, my X is in the minus, my Y is in the minus, and the Z is in the plus. Okay. Now, the switch position is for the X, that's 0. That's going to be 0. The Y limit switch, when it goes off, that's going to be 0. And the Z limit switch, when it goes off, for me is 4.3. So what I did was I brought my Z all the way down to as far as it could go. I didn't have a router bit in it, just brought it all the way down as far as it could go till I hit my limit. My Z negative limit, as far down as it could travel. I backed off that limit by about 10 thousandths of an inch, and I zeroed out the Z, and then I raised the Z up until the sensor became active, and whatever number it read in there was the number that I put. And in my case, you can see that the sensor is 4.3060. I have it set to 4.3. Okay, and it will vary from time to time. Now, so that's my switch positions. Z is 4.3 inches up from, that's where it stops. It limits itself. Y is 0, and X is 0. Now, after it does the homing procedure, where I want the axis to move to, I've got my X, Y, and Z settings in here. And so the Z, from that 4.3 inches, it's going to drop down to 2 inches. From that location, it's going to drop down to 2 inches, and it's going to stop there. That's going to be my, home position when it's done, if you will. The Y is moving over 2.32 inches, 3268 inches, and the X is moving 4.6977. Now, where did I get these numbers from? Well, on my machine. So on my table here, where my fences are on my wasteboard, where all my boards get clamped and everything, this corner is my X, Y, and Z0 for my material, my work position now, right? That's my work position and everything. And so what I did is I have the DWC quick set block. I put that block on there, and I did a touch off for X, Y, and Z. And the only two numbers that I was concerned about were X and Y. I wanted that reading. When that zeroes out on that block, that X and Y, that's the corner of my material. And so it zeroes out the machine here. Well, from there, I ran the X to its limit, the Y to its limit, and whatever number was in my settings is the number that I put into the these positions. And for me, the X position was that corner of that board location was 4.6977 from 0. The Y was 2.3268, and then of course I didn't have my Z come down to 0, of course, because my router bit lengths are going to vary, right? Whatever I have in there, so I don't want to bury them down in the table. So I just had the Z coming down to 2 inches above, or from that sensor, 2 inches and all, and that's how I got those numbers. Now, the switch click distance, when that sensor is active, how many micro steps, how many 10,000ths of an inch steps do I need to move before that switch turns off? And that switch click distance for me is 0.08. And so that is what I have set in there, and that's set by default for your machines. If you look at your home position, that's set by default, and that's it was very close to what I have. I think mine was 0794, something like that. So I left it at the 0.08, and I'm just fine with that. So once again, the speed of the touch off. Or the sensing, how when it goes to do the home procedure, I'm running at 20. You can run a little faster if you want, but I'm doing 20 with a low speed. You want the low speed to be slow. I'm going 5 inches a minute. I'm doing the Z first, then the Y, then the X. My X moves in the negative direction to go to that sensor. My Y moves in the negative direction to go to that sensor. And my Z moves in the positive direction to go to that sensor. My sensor positions, when it touches off and when they're all tripped, my machine position is 0, 0, and my Z is 4.3. From there, when it's done touching off, it's going to move to this location. And let's take a look at how that looks when we actually do a homing procedure. For time's sake, I just moved my router a little bit closer and everything. Now from here, I'm going to do a homing procedure, which is this little home button right here in the software. When I do, then we will switch over to the camera so you can see the actual movements and everything for that and where the router goes. Once I click on that home button, it'll do its homing procedure, and then it'll move to its work offset location, which for me is the corner of the board here. And that'll be its work position. That's where every time I do a homing procedure, it comes back to this location here. My Z does not come all the way down because I don't know what size router bit I'm going to have in there at the time. So it just comes down to the 2-inch mark and it stops there. From there, I will always reset and touch off my Z with my quick set block or my touch plate. Okay. but I should pretty well land on my corner each time. I can still use my touch block to do a touch off and all. That doesn't change and everything, but from my homing procedure, I should be able to get back to that spot each and every time. So let's go ahead and run a home procedure so you can see how that works. All right, so once we press that home procedure button, the Z is going to raise up and sense, and then it's going to move down to that 2-inch mark. My Y is going to move over and sense, and it'll do it twice, and then it's going to move to its position, and then my X will come in and sense. Once it senses, it'll back off and do it again a little slower. And then it's going to move to my home position. And if I were to lower my Z axis down, and if we were to look at that as a close-up, so if we were to look at that where it moves to, now of course I lowered the Z down, but my center of my bit should be split on my X-axis, as well as if I come around the corner on the Y, and which is the corner of my material. And so after the homing procedure, that's the location it goes to. And of course, as far as the Z is up 2 inches, right? That's where I have it stopped there. It was 2 inches. I would absolutely set my Z. I would take my touch block and touch off my Z. I would not. Your Z is not set at this point. It is reading 2 inches, and that's 2 inches from the bottom of the router to the top of my wasteboard. It's not accounting for my wood and my bit and all that. So you do a Z touch off. I can set my Z and be good. But so every touch off, every homing procedure that does, if I need to rehome the machine, power goes out or something like that, I can rehome the machine and get back to the corner of my material that way. All right, so my machine has done its homing procedure. Z has sensed, Y, then X, and then from there it's moved over to its stopping point, the location that I told from 0. That's my 0, the home where those sensors are getting activated. That's 0, 0, and 4.3, right? From there, goes down to 2 and it moves over to that location, and that location is the distance from 0. It's the machine's absolute position from 0 and everything. And so for me, I've got it set up to where it goes to the corner of my board. And once again, to illustrate how I did that is I had my board clamped in against my fences. I put my quick set block on, and I did a touch off procedure with the quick set block, which found X, Y, and Z of the board, the corner of the board. From there, it zeroes out that location as 0, 0, 0 for the board. From there, I raised my Z up to it limit itself out, and that number was my Z limit number. My Y, I moved it over to it limited itself out, and that was my Y location number. And then my X, I limited it out, and that was my X limit number to the move to location in the software. When we're in the software under the settings, home, that is the move to location. Okay, so the move location is where it moved to. All right, now from there, okay, now I have a certain distance that I can travel in Y positive before I hit the side of Y positive, right? Because I don't have a limit switch over there. There's only a certain distance I can travel. X positive, there's only a certain distance I can travel before I hit my limit there. Z down, there's only a certain distance I can travel before I hit there if I didn't have a router bit in my table, right? Or in my router. I didn't have a router bit on my router. There's only a certain distance I can travel before I bottom out, before I hit my limits in X positive, Y positive, and Z minus. There's only so much travel I can do. And I don't have limit switches over there. So what can I do for those sides? I can set in the software what's called soft limits. So let's go back to the software and let's look at that. So if I go back into the settings here, I have an option above limit switches is limits. And in my limits, above limit switches is limits. In my limits here, I have these soft limits set up. For my X, I have a negative 0.75 and my Y negative 0.75. But notice these two white buttons here are not active. I don't have them turned on because I am not my 000, because all my limit switches are on the negative side for these two. So I have that turned off. But my Z limit is turned on and it's set to 0. So when it counts down from that 430, that's as far as it can go down, is 0, and it stops there. My Z positive I have set to, that actually number should be 4.30. Actually, I want that to set to 4.5 because it's a soft limit and my sensor is running the X positive, so that's fine. I'll just leave it at 4.5. But these numbers here are the distance that I want to travel, my X and Y. X positive and Y positive locations where I don't have limit switches, those are active. So I've got X, Y, and Z active here. And X, I've got my X set to 3.92 or 39.92, sorry, 39.92, and my Y at 23 inches. Your digital wood carver has a carving area of 24 by 40, right? But remember what I said, I've got that metal 90-degree angle iron in my limit switch on the Y, which takes up about an inch of my movement. So I can only really move across the table 23 inches. I lost an inch, I burned an inch before I hit that edge over there, before I hit that positive. And on my X, my 39.92, I'm just 0.07 70 thousandths away, or 80 thousandths away from my 40 inches. So I lost a little there. So if we looked at the machine and everything, if I were trying to travel in the software and all, if I were moving let's click OK here. If I were moving my axes around, my Y positive, let's go into a different screen here. You should still be able to read those numbers there and everything. But if I move my Y positive, I'll use my controller for this here. And let's turn up the speed there and have it go across. I'm going to run all the way across. I don't even need to look at it because it's going to stop because of the soft limit. So in my case, it's 23.001. And if we look over to here, I've gone to my limit there. And I've left, I've got a little bit of room left before I would have crashed into that side. As far as the X-axis, so let's move the Y back towards me here. Okay. On my X-axis travel, if I were traveling the unit back, and again, I am, looking at you guys, right? I don't need to watch my machine because that soft limit is active. So holding that down, the unit is going to stop before it gets to that limit, that 39.9 and everything. So the soft limits from my home position, that's as far I in the software how far I wanted the machine to be able to travel. Those soft limits, I've got it set up, and now I'm not worried about hitting my my limits and all and everything. As far as the Z down, I have a wasteboard on my table and I've got a touch pin in there. But if I were to lower my Z down, it will stop. That's as far as it can go, is set to 0, which is roughly the top of my kind of wasteboard. But again, if my Z, that's as far down as it's going to go. It's going to stop at 0, right? And that's even if I was, holding the button down, that's as far as it's going to go. So my, if I back off that X again, and I'm holding that button down, that travel, it's going to stop automatically. That's as far as it's going to go. And on the Y-axis, let's move up a little bit so we can turn the camera so you can see that Y movement. And if I held down my Y positive and everything, it will, before it crashes into that side, it will stop at that 23 inches. Okay. So I have, effectively set my, X, Y, and Z. Now, if I wanted to bring the machine back to XY0, I still could click in my software, my move to 0XY, and of course that will move the machine back to its limits, of course, its home position, right? The homing position on its sensor. And, that is its limits before it's sensed and everything. And the emergency stop kicked on here because the sensors activated, sensor 1 and 2. Let's look at that on the screen, in the big screen. And the emergency stop activated because sensors 1 and 2 set themselves, right? So it stopped itself from crashing into 0, which is what it's supposed to do, and all that wonderful stuff. So it kind of keeps things from crashing. Now, if I return back, if I do a homing procedure once again, let's turn off the emergency stop. And if I run a homing procedure, it's going to sense X, Y, and rehome itself. And if we look at the where I'm at in my position, the bit is back over that corner location and everything. And again, if we look at that location, it's right at the corner of the board. All right, ladies and gentlemen, well, that is a run through on setting your limit switches. So here's a breakdown, a very quick summary. I've attached 3 limit switches to my CNC machine: X minus, Y minus, and Z positive. Those are the 3 locations. That where that machine comes and does its homing procedure, that location is our 0, for the X and Y, and 4.3 for the Z when it's raised up, in its maximum travel. From there, when it does its sensing, it comes back to a fixed location, to the move to location that I told it to go to. But I've attach those limit switches. From there, I have soft limits for the amount of travel that I can go in the Y direction, to the positive Y, and the positive X, and the negative Z. So 23 inches I have on the Y, because I burned an inch because of my proximity and sensor and everything. 39 point, I believe it's 39.1. 39.2, but that is the maximum distance I can travel on my X before it stops itself from crashing into the end. And then Z, it'll stop itself at 0, which you know, that is the soft limits that I have, the limits that I have set. But I will do my best to create a PDF that shows kind of some wiring schematics on how I wired it, and then how Planet-CNC recommends it being wired, and then through octocouplers and everything. I'll try to prepare and have something, a PDF document, a downloadable PDF document out soon, showing those schematics. And then as far as setting your homing procedures on planet-cnc.com, actually, not just planet-cnc.com, but in your Planet-CNC software, in your help user manual, there's a manual on setting up your home procedure and stuff. But basically, I had to tell it where the limit switch is. First of all, which limit switch was what. X is number 1, Y is number 2, Z is number 3. Then I had to tell it the location of those sensors. Y is in the minus direction, X is in the minus direction, Z is in the positive direction. That's where the location of those sensors are. Okay. And then for the homing procedure, which axis do I want to touch off first, or sense first, then second, then third? I always sense the Z first. I raise that bit up to the sensor, and then Y, and then X, and then have it move to a certain location. And for me, it's the location on my table where my fences are, where my boards are going to fall. All right, hopefully you found this interesting. Again, this is a guide, just kind of a getting started guide to point you in a direction. You're going to do your homework. These proximity sensors, I like them a lot. Now, when it comes to that, they're on Amazon. I gave you the link for that. You can go back in the video and kind of pause so you can see the name and those products. That would be the way I would go. But of course, if you find some better, fine. But of all the homework I did on the actual sensors themselves, I really like these, and they're doing great for me so far. The 100 NF capacitors, you can order them online as well. I happen to have an electronics store down the road, so I was able to buy a little 5-pack. It cost me 50 cents for 5 of those. If you do decide to go the octocoupler route and everything, you can order those from planet-cnc.com. Yeah, so other than that, use this as a guide. Do your homework. Remember, when you're drilling and tapping anything on this machine, that you absolutely take your time. Do not rush. Don't have, where you have, a time restraint. Oh, I got to get this done because we're going out to dinner tonight, or the dogs are running around driving me crazy. Whatever the case may be, focus on what you're doing, because any wrongdoing could damage, especially when I'm doing the Z-axis here. I'm drilling and tapping into the side of that bearing, the upper side, but being off slightly, I could have drilled into that bearing and damaged it. I could have drilled, if I was drilling that hole and I drilled all the way through and let it punch through, I could have marred my drive rod, and that marring could screw up my bearings on the travel. There are a lot of ways that you could make mistakes if you don't focus on what you're doing and really take your time. Think it out thoroughly. You have to make that gut decision, that feeling that I'm going to take the responsibility. It's my machine. I paid for it, right? I'm going to do this, and you're taking on that responsibility, because none of that is warranted by, Digital Wood Carver. Like I said, this is, Burl didn't call me and say, hey, I want you to make a video on how to hook limit switches up. This is a customer that asked. I'm showing you my approach to it. I've talked to Burl. I've talked to Planet-CNC, got their intake, and then I went with how I did it. But I'm trying to provide you with as much information as I can, so that you have a starting point. From there, you can go down that rabbit hole and dig a little deeper, right? All right, folks. Well, hopefully you found this interesting and helpful. And until next time, I'll see you soon.